Hello and welcome to today's lecture. We are still on module 3. So we're going to continue module 3. Today we're going to talk about algebra. Well, first of all, recall that. In algebra, if you have 2 points, we can write equation of a line. So suppose you have 2 points, then we can write equation of a line passing through those 2 points. Give us an example. Well, example. Suppose you have 2 points. Let A be the point with first coordinate 1 and second coordinate like 3. And B be another point with first coordinate equals to, let's say 4, and the second coordinate, let's see. Here, I'm going to give you something so you can easily simplify. So let us write 9 on the numerator here for the second coordinate. Very well. So what do we have here? We have 2 points. The first coordinate of the point X, the second coordinate of the point Y, so X coordinate and Y coordinate. For the second point B, the first coordinate is 4 and the second coordinate is Y. What is our goal? Our goal is to write equation of a line passing through these 2 points. Question says, write equation of a line passing through these points, points A and B. Well, how do we write equation of a line? Remember that last time we said equation of a line can be written as y equals to mx plus b. M is slope of the line, so M is a number, slope of a line, and B is the y-intercept. B is another number, y-intercept. Well, how do we find slope or M? M follows a nice formula. To find M or the slope, we have the following formulas. Slope or M is equal to the difference in y values, rise, difference in y values divided by the difference in x values. Run. So rise divided by run. Very well. So first let us find the slope of this line. So M is equal to the difference in y values. You can take the first y minus the second y, or you can say that, hey, the second y minus the first. So difference in y values. Remember that if you select 3 minus 9, on the denominator you have to subtract 1 minus 4. So order is very important. Which point is your first point? You have to stick to that. So you have 3 minus 9, or you can say that, hey, 3 minus 9 is a negative number. I'm going to subtract 3 from 9. So I'm going to start by writing the second point first. So 9 minus 3 divided by difference in x values. Since we started by writing 9 first, we have to start writing for the first coordinate of the second point first. So it's going to be 4 minus 1 x value. So what do we get? We get 9 minus 3, which is 6. 6 divided by 4 minus 1 is equal to 3. 6 divided by 3 gives you 2. So m, or slope of the line, is 2. 2, a positive number. It means that your line is an increasing line. The positive correlation between x and y is coming from slope equals to 2. Well, are we done? Not yet. We found m. What is missing? B is missing. So you can write some part of the equation this way. We can write, hey, my y, or my dependent variable, is equals to 2 times x, 2, which is the slope is 2 times x, plus another number which I don't know what that is. How to find b? To find b, you can either work with a, or you can work with b. So let us write this here to find b. Let us use a. It doesn't matter if you use a or b. Your y-intercept is going to be the same. So I'm going to use point A with first coordinate 1 and second coordinate 3. So I'm finding this missing value. Y is equal to 2x plus that missing value. For this case, I have my x equals to 1. I have my y equals to 3. So I can substitute them here into equation of the line for this specific point to find my b. So 3 is equal to 2 times, what is your x in this special case? Your x is equal to 1 plus the missing value, b. So 2 times 1 is just 2. 3 minus 2 is equal to 1, so b is 1. Very well, I found my b. I'm going to write it here. And this is the equation of the line passing through these 2 points. Well, now I expect you to ask, last time we talked about scatter plots. We had a lot of different points in xy plane, and you start talking about regression line. A line y equals to mx plus b. Now that I have, for example, 10 points, I have 100 points, I have 1,000,000 points. How can I write equation of the line? So recall last lecture, we start introducing the regression line. A regression line is a line passing through the points when you have scatter plot. So suppose we have a scatter plot this case. Remember that on horizontal axis, you have your x values. It means that you have explanatory variable values or free variable independent. And your y variable depends on x. Here we go. Here we have our y, which depends on x. Dependent or response. Well, suppose you have relation between the amount of fat and the rating. Okay. Amount of fat in the cereal and rating. Suppose you have these points, scatter plot with 76 dots, a lot of dots, so many of them are missing here. Very well. So remember that the trend or the correlation in this case is a negative correlation. Why is that? If you consider the regression line, the line that passes through these points, this is your regression line, this is a decreasing line. Regression line is decreasing. Well, it's decreasing, it means that slope of the line is negative. It's a negative number. So I expect you to ask, what is the equation of this line? How to write? Equation of the regression line. Very well. First of all, note that when we are working with regression line for a sample, we use this symbol, y, and we put a little bit of hat on top of it. It is equal to mx plus b. To write equation of a regression line, we usually use a software or a calculator to write this equation. We use calculator or software. After the calculator or software give us the equation of a regression line, your job as a statistician is to analyze the behavior of your data based on this equation and make predictions. Now, you can make predictions. Well, let's take a look at our notes. We are on module 3, part 2, using lines to make predictions. Statistical methods are used in forensics to identify human remains based on the measurements of bones. In the 1950s, Dr. Mildred Trotter and Dr. Golden Glasser measured skeletons of people who died in the early 90s. From these measurements, they developed statistical formulas. So note that they had data, and based on those data, they came up with formulas for predicting a person's height based on the length of various bones. These formulas were first used to identify the remains of US soldiers who had been buried in unmarked graves in the Pacific Zone during World War II. Modern forensic scientists have made adjustments to Trotter and Glasser's formulas to account for the differences in people living now. So we will use a process similar to what they did in this problem. Let's see if we can identify a female student based on the length of her forearm. The mystery student has a forearm measurement of 10 inches. She is alive and healthy. Well, our task is to determine if the mystery student could be one of the 3 female students. To accomplish our task, we have gathered evidence in the table below. Our evidence lists the heights and ages for 3 female college students. So for the first student, the age is 18, female, 5 feet and 5 inches. That's the height. For the second one, the second student, the age is 23, female, 5 feet 2 inches. And for the last one, the age is 33, female, and 6 feet. First, we need data to help us see if there is a relationship between forearm length and the height for female students. Okay, very well. We're going to, for now, use a scatter plot. The scatter plot below is a graph of forearm length versus height for 20 female college students taking introductory statistics at Los Medanos College in Pittsburgh, California in 2009. Okay, here we go. We have our scatter plot. Let us take a look at the scatter plot. Let's try to analyze the scatter plot. What do we see? What is the trend that we see here? Do you see a positive correlation or do you see a negative correlation? How do you analyze this correlation? Very well, it's a positive correlation. Thank you. Thank you, Anna. Thank you, Christina. Very well. Ketra, thank you so much. Here we go. Take a look at the trend here. As you can see, here you have a positive trend or positive correlation between X and Y. So if you want to think about regression line, your y hat is equal to mx plus b, and m as the slope of the line is positive. We get a positive number. We don't know what that number is, but for now, we have these information about the scatter plot. Very well. So let us answer these questions. Based on the scatter plot, what is a reasonable prediction for the height of the mystery student? 2, there is a lot of variability in our data. Variability, it means that you see there are actually distances between these points. They are far away from each other. So as you can see, here you have variability in your data. This variability can make it difficult to determine if one of these students is the mystery student. One way to help solve the mystery is see if we can eliminate any of the 3 students. Could any of the 3 students be eliminated as the mystery student? Explain your reasoning. Take a look at previous page. We're going to identify a female student based on the length of her forearm. The mystery student has a forearm measurement of 10 inches. 10 inches, okay. Let's take a look at the data that we have here. 10 inches. We're going to predict the height. So 10 inches, the forearm. So if you just go further up, you can see the first point here. You might say, hey, this is close to 10 as well, or this point. So if you look at the measurement of forearm, for the first point, for the second point, for the third point, they're close to 10. So you might say, hey, for the first point, the height is near here. The second point, the height is near here. And the third, the height is near here. So you get 3 predictions. 3 different predictions. There are 3 predictions for the height. Very well. Next steps. Using a line to make predictions, the scatter plot shows a positive linear association or correlation between forearm and the height. So forearm is your x, free variable, and the height is y, dependent variable measurements. The correlation is about 68%. Guys, if you have your points, if they have all points, we can use a software or calculator or software to actually give us this m or slope of the line, which is fairly strong. It means that it's a positive number and it shows a good correlation, positive correlation between forearm and height measurements. Since the correlation is fairly strong, it makes sense to use a linear model. It means that using a line, y equals to mx plus b, this is a linear model. To summarize the relationship, in statistics, there is a line that will give us the best description of how height and forearm length are related. We will call it the line of best fit, or another name for it is the regression line. The line of best fit is the line that represents the center of a linear pattern in a scatter plot. We will learn more about how to find this line in future lessons. Very well, for now, we will give you the equation of this line. Here we go. This is your line, and this is your scatter plot. A. The line of best fit or the regression line is drawn on the scatter plot above. Use the line of best fit to predict the height of the mystery student. Remember that the forearm measurement for the mystery student was 10. So based on your linear model regression line, it fits to this point at the line. So if you match it to the vertical axis, you have your height. Like you can say it's 66, yes, 66 inches. So the answer to A, using the given regression line, since our x is equal to 10 inches, our y or the height is 66 inches. Well, let's take a look at the given equation. The given equation of the regression line is given to us as 2.7 times forearm length plus 39. So y hat, or the predicted height, is equal to 2.7x plus 39. If you use your y equals to mx plus b, equation of a line, as you can see, m, or slope of the line, is equal to 2.7, and b, or the y-intercept, is 39. Then we use letters to represent variables in the line of best fit or regression line. We put a hat on the y and we write y hat instead of y. The hat is a symbol that tells us that we are making an estimation. Results from a line of best fit equation do not represent the actual data values. You're just making an estimation or approximation. Use the equation to predict the height of the mystery person. Is the height of Jane Doe 1, Jane Doe 2, and Jane Doe 3 closest to the predicted height of the mystery student given by the line of the best fit? Well, let us take a look at our table, the information that was given to us. The age 18 and the height 5 feet 5 inches. Remember that you need to convert each of these into inches. So first convert the height of the first student to the inches, the height of the second student into inches, and the height of the third student into inches. Why is that? Because our vertical axis is height in inches. Here you have to convert each of the height into inches to check to see which one matches the best predicted value by our regression line. So this is our regression line. What are the given heights? So first we convert 5 feet 5 inches by multiplying 5 feet by 12, because we have to convert feet into inches. You get 60, 60 plus 5 is 65 inches. So let us find 65 inches here. 65 inches. 65 inches matches to this point, which is close to, almost close to 10 inches of forearm. So this is your first student. The second student has height which is equal to 5 feet and 2 inches. 5 feet and 2 inches. So this is just 65. This is 60 plus 2, 62 inches. 62 inches, take a look at 62 inches. They're getting far away from 10. So 62 inches is going to be roughly here. So it's just this point, maybe here. So as you can see, the measurement of forearm is getting smaller. This is for the second student, student number 2. So student number 2 is not going to be a good candidate. S2, and this is S1. What about S3? The third student with forearm, which is missing, but we have the height, which is 6 feet. So you have to multiply 6 feet by 12. You get 72 inches. 72 inches of the height, let us match it. 72 inches is going to be roughly here, this point. So if you match it to the horizontal axis, you get almost 11 as the measurement of the forearm. So this is your third student. So third student is not going to be a good candidate. The first student is a good candidate because its forearm is close to 10 inches. Very well. So our next stop, the scatter plot below represent body measurements in centimeters and weight in kilograms for 34 adults who are physically active. The first one, type girth and the weight, and the other one is bicep girth and the weight. Based on these data, which do you think is a better predictor of an adult's weight? Type girth or the bicep girth? Why do you think this is the best predictor? First of all, remember that as long as you see a better fitted line, what do I mean by that? A better correlation between X and Y. it means that your line is actually has slope close to 1. It means that you have a stronger correlation, better correlation, better prediction. So which one of these two lines has a slope close to 1? Of course, the second line. The second line actually gives you a better prediction. So the answer to question 4A is the second line. Let's take a look at some graphs, some lines, and actually compare the slopes of those lines. Very well. So I'm going to use Desmos online graphing tool that is free for you. You can use it. Suppose my line is y equals to, so I'm going to start by giving different numbers less than 1, and I'm going to have positive slopes. So suppose I'm going to start by 12% x plus, I'm going to give y-intercept to be 2. So this is my first line. As you can see, my slope is 0.12. I'm going to give you a different line. Y equals to, I'm going to increase the slope. Now I'm going to use 0.32x plus 2. So what I'm doing, I'm increasing the slope of the line. It was 0.12. Now it is greater than 0.12, which is 0.32. I'm going to change the slope to give you a better, nicer slope. Y equals to 0.52x plus 2. So this is my new line, the green line. As you can see, the slope is getting larger and larger, and my goal is to have slope which is close to 1. Another line for you, 0.72x plus 2. My new line here, very well. Next line, y equals to 0.92x plus 2. Very well. As you can see, 0.92 is very close to 1. Is very close to 1. And I have much better correlation, association between x and y. Why is that? Because the slope of the line is getting closer and closer to 1. That's what is happening here. As you can see, the slope of the line is closer to 1. So we say that we have a better association or correlation between bicep girth and weight rather than tight girth and the weight. Part B, Adriana has a tight girth of 57 centimeters and a bicep girth of 25 centimeters. Predict her weight using the graph that you think will give the most accurate prediction. Very well. So we have the tight girth, which is 57. 57 is a number close here. Okay, very well. So if we use the regression line, we expect the weight to be close to 70 kilograms. If we use the bicep girth, 25 is here. The weight is actually 55. So do you see there's a huge difference between the weight of the person? 55 based on the bicep girth and 70 based on the tight girth. So as we mentioned before, our second graph gives you a better prediction. So we expect the weight to be actually 55, not 70.